Hello everyone, welcome to my channel. Today we will begin a new topic, haloalkanes and haloarenes. Haloalkanes and haloarenes. Now, from its name, we will try to understand what are haloarenes and what are haloalkanes. Halo means halogen. Alkanes is carbon chain having all single bonds, alkane. Now come to haloarenes. This is arene means aromatic ring, and this halo means again halogen. So haloalkanes are the compounds. If we replace, let's say this is ethane. If we add halogen in this compound and replace the hydrogen, then what will become? CH3, CH2. In place of this hydrogen, what you will get? X. This X is halogen. So, when we remove from alkane, hydrogen is removed and the halogen is added, then it will convert it into haloalkanes. Similarly, in case of arenes, this is arene. We all know that there is one hydrogen attached to each carbon atom. So, similarly, halogen is added and hydrogen is removed. From any place, this hydrogen is removed and on the same place, this halogen will get attached. So, these are called haloalkanes and haloarenes. They are also called alkyl halides or aryl halides. Now we will discuss the classification of haloalkanes and haloarenes. It is classified on the three bases. First one is number of halogen atoms. First basis is number of halogen atoms. Second is number of carbon atoms. Third one is hybridization. Now on the basis of number of halogen atom, first one is mono-haloalkane. Second one is dihaloalkane. And third one is C part. This is polyhaloalkane. Now if we talk about on the basis of carbon atom, it is primary, B1, secondary, third one is tertiary. Now if we discuss on the basis of hybridization, sp3 hybridization, sp2 hybridization. sp3 hybridization, allylic, benzylic, and sp2 is vinylic and arylic. These are all the types of haloalkanes and haloarenes. Now let us consider examples. Mono-haloalkane means haloalkane containing one halogen. Mono means one. So this will be CH3, CH2, X. Only one halogen is present. Halogen is basically represented by X. X may be fluorine, chlorine, bromine, iodine. So don't get confused if I write X. Next, di. Di means 2. Haloalkane means there is 2 halogens. There is 2 halogens. In dihaloalkane, there are 2 possibilities. Geminal dihalides and vicinal dihalides. Now, what is the difference between geminal and vicinal dihalides? Vicinal dihalide is this type of dihalides where both the halides are present on different carbon atoms. Different carbon atoms but in the pattern 1, 2 means on the adjacent carbon atoms. When this situation is this, then that dihaloalkane is vicinal. But in case of geminal, if both dihalides present on single carbon, on the same carbon, then it is called geminal dihalides. Clear? If both are present on different, then it is vicinal. If on the same, then it is geminal. Next is polyhaloalkane. If any compound having more than 1 chlorine, more than 2 chlorines, this will be the example of polyhaloalkane. Monohaloalkane, 1 halogen. Dihaloalkane, 2 halogens either on the same carbon or on the adjacent carbon. Polyhaloalkane, more than 2 halogen groups are present. Next category is on the basis of number of carbon atoms. On the basis of number of carbon atoms. Which carbon atom we are talking about? We are talking about this carbon atom, which is attached to halogen. Now see, if we are dealing CH3, this carbon, here is hydrogen, here is again hydrogen, and this is halogen. Now see, we are talking about this carbon atom. If this carbon is attached to single carbon, then it is primary. Now, if this situation arises, this same carbon connects with 2 carbon, then it is called secondary. And last, when it is connected with 3 carbons, then it is called tertiary. And now come on the basis of hybridization. In hybridization, we are again talking about this carbon. We are dealing with the hybridization of this carbon which is directly attached to halogen. Now this is allylic. First we have to understand what is allyl. When this type of bonding is there, this whole group is called allylic group. Double bond with single bond, there is halogen. This group is allyl and this whole compound is called allylic halide. Now we talk about benzylic. Benzene, on the benzene there is CH2. On CH2 this halogen is attached. This is benzylic halide. Now next is vinylic halide. Here you can see this carbon is sp3 hybridized and this carbon is sp3 hybridized. So we are consider sp3 hybridization. Now see sp2 hybridization. Vinylic is CH2 double bond CH. Here X is present. Now see what is the difference between allylic and vinylic. In allylic, halogen is attached to the carbon atom which is next to double bond. But in vinylic, halogen is attached to that carbon atom which is a double bonded carbon atom. This is the difference. Now arylic. Again we draw benzene ring. Now see the difference between these two. Here this carbon is sp2 hybridized. This carbon is also sp2 hybridized. This carbon is sp2 hybridized and this halogen is directly attached to the benzene ring. But here this halogen is attached to the carbon which is attached to benzene ring. So this is all about the classification of haloalkanes and haloarenes. Now we will deal with the nomenclature of these haloalkanes and haloarenes. Nomenclature. Now see, for nomenclature, our first rule is select the longest parent chain. Select the longest parent chain. Second one is numbering will be given. Lowest numbering will be given to functional group, any substituent or double bond. Any substituent or double or triple bond. This will be on the basis of priority. Now, priority is function group is more prior, then double or triple bond, then substituent, then normal chain. This is the priority. Now let us consider one example. CH3 Now, let us consider this example. What will happen? First, we have to select the longest parent chain. Longest parent chain is 1, 2, 3, 4. This will be your longest parent chain. Now, you can tell me, the numbering is done from this side. This numbering will also done from this side. Which side we will prefer? We will prefer that side from where this chlorine will get the lowest number. From this side it will get the second number, and from this side it will get third number. So we will prefer this numbering. According to this, first we have to write down the substituents. On the second position there is 2-chloro. Chlorine is written as chloro. Now, is there any other substituent? No. So, we will take the parent chain 1, 2, 3, 4. For 4, we are using but. All are single bonds, so we are written butane. Now, if we take one more example, CH2 double bond CH, C, Cl, CH3, H. Now, here is the double bond as well as the substituent. To which we will give the more preference? Double triple bond or substituent? Double triple bond. So, what will be its name? So, numbering will be done from this double bond side, so that this double bond will get the lowest number. So, then this is but. Their substituent is on third position, 3-chloro. Next 4-carbon but. On what position? Double bond. Double bond is present between first and second carbon. So we will always write the lowest number. Lowest number is 1. So but 1-ene. So this is on the basis of preference. Now let us consider one more example. In this case, see clearly which longest chain we will prefer. First, 1, 2, 3, 4. 1, 2, 3, 4. Is there any other way to find the longest chain? 1, 2, 3, 4, 5. No. See, 1, 2, 3, 4, 5 and 6. We will select this longest chain. Rest all will be your substituent which are outside this longest chain. So what will be present? 3. Now here is chloro and methyl. First name is written as chloro because it will be alphabetically. Chlorine is chloro begins with C and methyl begins with M. C occurs initially in ABC. So, due to these reasons, we will name chloro first. So, it will present on third as well as on fourth position. So, we can write together 3,4 dichloro. Now, put hyphen. In between the alphabets and numbers, you have to put hyphen. This is done. Now, what is present? Methyl. On the same position, 3,4 dimethyl. Is there anything other present? No. Parent chain is simple hexane. So it is written as 3,4 dichloro 3,4 dimethyl hexane. So in this way, you will get a number of examples for nomenclature. Now we will deal with the haloarenes. Similarly, we can nomenclate haloarenes. Let us consider 1-2 examples for haloarenes, as well as we have some cyclic compounds. Now, if we see this compound, there is Cn. Now, what's the difference? The difference between these two compounds is this ring is aromatic ring and this is normal cyclic ring. So what will be happen for the nomenclature? 1, 2, 3, 4, 5, 6. First position will be given to that part where the substituent is given till other substituent is not present. So it will become 1 chloro. This is 6 membered. When it is normal cyclic ring, we will write cyclohexane. Now, in this case, if this will be happen, here is bromine present and here is chlorine present. Now, we have to give the number 1, 2, 3, 4 or 1, 2, 3, 4. We will prefer that numbering from where this bromine and chlorine both get the lowest number. So, we will prefer this numbering. 1 bromo. First we will write bromo because B comes first. 3 chloro. Cyclohexane. Now, this is chlorine is present. So, it is chloro. On which position? 1. 1 chloro. This ring is benzene. So this is chlorobenzene. If there is chlorine and there is bromine, now what will happen? 1, 2, 3. This will become 3 bromo, 1 chloro, benzene. We can also write it as meta bromo chlorobenzene. This is its common name. How we can write it? This whole is chlorobenzene and on its meta position, this is ortho position. These both are meta positions and this is para position, and on the meta position there is bromine is present. So meta bromo chlorobenzene is the entire ring. So this is all about the nomenclature. In the next video, we will discuss about the methods of preparation. That's all for today. Thank you and have a nice day.